Hi guys, how are you? I hope you are doing well. Today we're gonna do sections 9.1, 9.2. That's hypothesis test for the population mean mu. So today we're gonna try to answer the following question. Is there strong evidence that the population mean mu is different from some value based on prior information? Okay, and the prior information actually is called the null hypothesis H0. So for example, let's say 10 years ago, the average height of NBA players, 10 years ago, average height of NBA players, let's say is, I don't know, let's say 6 feet, okay, 5 inches, okay. So in this case, the prior information here, or the null hypothesis H0, is that the average height, mu, is actually equal to 6 feet 5 inches. So here in this case, the prior information so the null hypothesis H0 is that the average height, so let's say mu 0, is 6 feet 5 inches, okay? So here, the average height, it's based on some prior information, right? So that's the 6 feet 5 inches. Now what we want to do, we want to test this prior information or this null hypothesis against one of some alternative hypothesis. So we want to test the prior information or the null hypothesis H0 against one of the following alternative hypothesis, and we're going to call the alternative hypothesis H1. Okay, so the alternative hypothesis could be that, so H1 could be that the average height is less than this the 6 feet 5 inches mu 0, okay? Or H1 could be, the alternative hypothesis could be that, you know, that the real average height is larger than the null hypothesis, so mu 0, okay? Or an alternative hypothesis would be that the real average height is different. So mu is actually different from 6 feet 5 inches. So it's different from the null hypothesis. Okay. So in case when the alternative hypothesis is your mean is less than your null hypothesis, then it's called, in this case, we have left-tailed test. Okay, it's left-tailed because it's on the left of the null hypothesis mu 0. If mu is larger than mu 0, then the null hypothesis. If your alternative hypothesis is that your average is larger than the null hypothesis, then that will be right. So it's on the right of mu 0, so it's a right-tailed test. Okay, and in case of that, your alternative hypothesis that your average height of NBA players is different from the prior information based on 10 years ago study, then that's a two-tailed test. Okay, so it's a two-tailed test. And actually the choice of the alternative hypothesis depends, so this choice of alternative hypothesis depends on the problem. Okay, so it depends on the question. I'm gonna have explicit examples later, and you're gonna see how it works. Okay, so but this alternative hypothesis depends on the problem. Okay. Okay, now there are actually two different scenarios. Like this is like analog to the section to the chapter 8, right? So there are two different scenarios. The first scenario is when sigma is known, and the second scenario is when sigma is not known, is unknown. Okay, so there are two different two different scenarios. So the first scenario is that sigma, the population standard deviation is known, so sigma is known. Okay, then in this case, when sigma is known, we're gonna use the z-test. Again, this is kind of analog to the chapter 8, so we're gonna use the z-test when sigma is known, and the test that's the test statistic, so z is equal to x bar minus mu over sigma divided by square root of n. Okay, and when sigma is unknown, okay, so we're gonna use, of course, the t-test. Okay, and the test statistic, so t is equal to x bar minus mu. So here sigma, the population standard deviation sigma is unknown, so we're gonna use the sample standard deviations. So s over square root of n. Okay, so of course x bar here, that's the sample mean. Okay, and that's the size of the sample. Okay, and of course S, that's the sample standard deviation. Okay. Now, then comes the p-value. The p-value is actually the probability of getting the observed value of the test statistics if the null hypothesis is true. So the p-value, that's the probability of getting the observed value of the test statistics. Observed value of the test statistic. If, of course, if the null hypothesis is true. So the lower is true. So lower the p-value, stronger the evidence against the null hypothesis H0, or stronger the evidence against the prior information. Okay, so lower p value, stronger the evidence against the null hypothesis H0, okay, against H0. Okay. And how do we compute the p-value? Well, let's say sigma is known, so we're gonna use so the test statistic would be given by the z-test. So let's say sigma is known. So the p-value would be, so there are three cases. If your H1, let's say H1 is that mu is less than mu 0, so then the p-value would be the probability that z is less than your z x bar. Okay, so here z x bar, that's the test statistic. okay? If, let's say H1, let's say mu is larger than mu 0, then the p-value would be the probability that z is larger than the zx bar, the test statistic. And if it's your alternative hypothesis H1 is that mu is different from mu 0, then the p-value would be 2 times. So here, just be careful. So here it would be 2 times p, the probability that z is less than minus absolute value of zx bar. Okay, so here be careful. So it's here, it's 2 times. Okay, so this is 2 here. Okay, it's 2 times. Okay. Okay, so once you compute the p-value, then you need to compare the p-value with the level of significance alpha, which is the probability of rejecting H0, the null hypothesis, when it's in fact true. Okay, so then we compare. The p-value with the level of significance. So this level of significance is given in the problem. So alpha. So it's given in the problem. So that's the probability of rejecting the null hypothesis H0 when it's in fact true. And actually, so the thing is, so if the p-value is less than alpha, then what you do is you reject. So there is a strong evidence against H0, so you reject H0 and accept the alternative hypothesis H1. So there is a strong evidence against H0, and if p-value is larger than alpha, okay. So if it's large enough, so we do not reject H0. So there is no strong evidence, not enough strong evidence against H0. So we do not reject H0. Okay. So anyway, to solve any problem, guys, we have the following steps. So the steps are the following. So first step is you state the null hypothesis H0. So first you state H0, okay, which is based on prior information. Okay. So then second step, you state the alternative hypothesis H1. You need to state H1, the alternative hypothesis. Okay, third step, what you do, you compute the test statistic. Okay, so here, so compute, third step, you compute the test statistic. Okay, so again, there are 2 cases, 2 scenarios. Sigma is known. Okay, then use the z-test. So z would be equal to x bar. So zx bar here. So it's equal to x bar minus mu over sigma divided by square root of n. If sigma is unknown, so we use the t-test, and then let's say tx bar would be equal to x bar minus mu over, so sigma is known, so we're going to use the sample standard deviation s over square root of n. Okay. Fourth step, you need to find the p-value. Find the p-value. Okay. Then and the fifth step, you compare the p-value to the level of significance alpha. So compare p-value to alpha, okay? And the sixth step, you can give your interpretation of the comparison between p-value to alpha. So here you give your interpretation to your answer. Okay. So let's do two examples. So first example, when sigma is known. Okay, examples. So first example 1. So this is when sigma is known. Okay, sigma is known. So let's say about 11% of US wheat crop is destroyed each year by the fires. Okay. So here, based on prior information, you know that the average, so you know that 11% of US wheat crop is destroyed by the fire, right? So let's now take a random sample of 16 regions. So random sample of 16 regions gave the average. So the sample mean or the sample average X bar. So the percentage of US wheat crop destroyed by the fire in the 16 regions is X bar is 12.5%. Okay. And let's say we know that the population standard deviation sigma is equal to 5%. Okay. So the question is, do the sample of the 16 regions indicate the percentage lost in US is different from 11%? So the question is, do the sample indicate the percentage lost in US is different from 11%. Okay, and we're going to use alpha equal to 0.01. So in this problem, we know that the average percentage of US wheat crop destroyed by the fire is 11%, right? That's our prior information. So first, what's H0 here? So first step, so let's state H0. So what's H0 in this problem? Well, so based on prior information, we know that the average percentage of US wheat crop destroyed by the fire is 11%, right? So the H0 here is that the average percentage of US wheat crop destroyed by the fire is 11%. So mu, so H0 here, so mu0 is equal to 11%. Okay, so that's the average percentage of US wheat crop destroyed by the fire. Okay. Now, what's the alternative hypothesis? Well, here in this question, you see, the question is, do the sample indicate the percentage loss in US is different from 11%? Okay. So we want to test the H0, the 11%, the average percentage of US wheat crop destroyed by a fire against the alternative hypothesis that it's different from 11%, okay? So the alternative hypothesis, H1, so here H1 is that mu is different from mu 0. That the percentage, the average percentage of US wheat crop destroyed by the fire is different from the 11%. So mu is different from the 11%, okay? So third step, so that's our alternative hypothesis. So we want to compare, again, we want to test H0, that the percentage average of US wheat crop destroyed by the fire is 11%. We want to test that against the alternative hypothesis that the average is different from 11%, okay? So third step, we said we need to compute the test statistic, okay? So here, the question is sigma known or unknown? Well, sigma is known here, right? So we know that sigma, the population standard deviation is 5%, so sigma is known. So sigma is known. So sigma is equal to 5%, so is known. So we need to use the z-test. Okay, so then z x bar is supposed to be equal to x bar minus mu over sigma over square root of n. Okay, so then z x bar. So what's x bar here? The average, the sample average, or the sample mean. The sample mean, we said, we have a sample of 16 regions, right? And gave the 16 regions, they gave x bar equal to 12.5%. So the x bar here is 12.5%. So x bar is 12.5% minus mu. That's our null hypothesis, H0. So it's 11%, so it's 12.5 minus 11, okay, over, and then sigma, which is 5%, so it's 5 over square root of n. So the n, that's the size of the sample. So here, so our sample here, we have random sample of 16 regions, right? So we have the size of the sample is 16, so n is 16. Okay, so 5 over square root of 16. So that will be equal to, so 11.5 minus 11, that's 1.5 over 5 over square root of 16, square root of 16 is 4. Okay. So Zx bar is equal to, so 1.5 over 5 over 4. So here, be careful guys, this is division. So this is like, here, this is 1.5 over 1 over 5 over 4. So this is like division of fractions. And when you divide fractions, we need to flip the fraction in the bottom. So that's 1.5 over 1 times 4 over 5. So that will be equal to 6 over 5. So then Zx bar, the test statistic, is equal to 1.2. Okay. Now, next step, we need to compute the p-value for the p-value. Okay. Well, here we need to check whether we have what kind of test we have. Do we have left tail test, right tail test, or two tail test? So here, remember guys, So how do we compute the p-value? Sigma is known. So if h1, you have mu less than mu 0, then this is our p-value. If mu is larger than mu 0, if the alternative hypothesis that mu is larger than mu 0, this is your p-value. If the alternative hypothesis that your average mean, your average or your mean is different from the null hypothesis, and this is equal to 2 times the probability that z is less than negative minus or negative zx bar. So we, in our case, in our example here, h1, you have mu different from mu 0, right? So we're gonna use the p-value is actually given by 2 times z, probability that z is less than minus or negative zx bar. So here it should be, so p-value here, so the p-value would be equal to 2 times the probability that z is less than negative zx bar. So my zx bar is 1.2, so z less than negative 1.2. Okay, so you can check your the z-score table. Okay, so for negative 1.2, so that's 2 times, I think, 0.1151. So that will be equal to 0.2302. Okay, again, I got this 0.1151 by using the normal standard distribution table, or the z table. Okay, this z-score table. So that's our p-value. This is our p-value. And now for a fifth step, we can now let's compare. Fifth step, we compare p-value with alpha, right? So p-value is 0.2301. Alpha, we said alpha, it's given in the problem. We said alpha in the problem. So here alpha is 0.01, right? So here alpha is 0.01. So of course 0.2302 is larger. This is larger than alpha, which is 0.01. Okay. So we said if the p-value is larger than alpha, then we do not reject H0. Right? We said here, so we said if the p-value is larger than alpha, then we do not reject H0, right? So then, so what will be the interpretation here? Well, there is not enough evidence to say that the percentage of crops destroyed by fire is different from 11%. So there is no, or there is not enough evidence that to say that the percent of crops destroyed by fire is different from 11% from the sample. Is different from the 11%. Okay. Now let's do another example. So example 2, this is an example when sigma is unknown. So example 2, sigma is unknown. Okay. So let's say x, the random variable, so be a random variable that represents random variable that represent hemoglobin count in grams per 100 milliliters of blood. Represents hemoglobin count in grams per, let's say, 100 milliliters, okay, of blood. Okay, and let's say we know that mu is 14 hemoglobin count, okay, based on a former or based on an old study. Okay. Now, so this you see here. So this prior information here, or the null hypothesis, is that your the average or the mean of the hemoglobin count is actually equal to 14, and because it's this 14 is based on an old study. That's our prior information. Okay. Now suppose you have suppose a female patient has lab tests in a year with hemoglobin count given by, so let's say she got 10 tests, lab tests. In the first lab test, let's say she had 15 hemoglobin count, then 18 the second lab test, then 16 the third lab test, 19, 14, 12, 14, 17, 15, and then 11. Okay, so she had 10 lab tests. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So the question is, does the information here indicate the population average hemoglobin count for this patient is higher than the 14? Question here, does this information indicate the population average of hemoglobin count, okay, for this patient is higher than the 14, which is based on old study, right? Higher than 14. Okay, so this female patient, she had 10 lab tests in a year, and this is the hemoglobin count for the 10 lab tests. Now the question is, does this information or this sample here indicate that the population average for this average of the hemoglobin count for this patient, okay, is higher than the 14? Okay, so let's see. So first, let's find the sample mean. So x bar, would be equal to 15 plus 18 14 plus 16 plus 19 plus 14 plus 12 plus 14 plus 17 plus 15 plus 11 over, so the patient had the 10 lab tests, so that's over 10. So that's actually x bar is going to be equal to 15.2. Now, second step, we need to find the sample standard deviation S. So S is equal to, remember S was the square root, don't forget to take the square root of, so sum of x minus x bar square over n minus 1. Okay, and then that will be 2-point standard deviation here, would be 2.51. Okay. Now, third step, what will be the null hypothesis here? What will be H0? Well, we know that, based on an old study, we know that the average or the mean of the hemoglobin count is 14. So the null test here is that mu, the average of the hemoglobin count, is mu is equal to 14. Okay. Now, we want to test this null hypothesis against what? Well, against, so this question here, you see, does this information indicate the population average for this hemoglobin count for this patient is higher than 14? So does the population average of the hemoglobin count for this female patient is higher than 14? Okay, let's see if it's higher than 14. So the alternative hypothesis H1 would be that mu higher. So mu would be larger than mu 0. Okay. So in other words, mu is larger than 14. Okay. So next, we can compute the test statistic, right? So test statistic. So here sigma is unknown. So we need to use the t-test. Okay. So the t-test, so t, let's say x bar, that will be equal to x bar minus mu over, sigma is now unknown, so we're going to use the sample standard deviation as over square root of n. So x bar, the average of the sample here, so it's 15.1, so here it's 15.1 minus mu. Mu is larger than mu 0 is 14, so over minus 14 over s, as the standard deviation is 2.51, so it's 2.51 over square root of what? Well, and she had 10 lab tests, so the size of the sample here is 10, so it's over square root of 10. So then, the t, the critical value, t here, so tx bar would be equal to 1.1 over 2.51 over square root of 10. So don't forget here, guys, when you divide, you have to flip, right? So this is actually 1.1 over 1 times, and you flip square root of 10 over 2.51, okay? So that's actually 1.1 times square root of 10 and divided by 2.51, okay? So actually tx bar is going to be equal to 1.386. Okay, now next, we need, the sixth step here would be to find the p-value. So the question here, is it a left tail test, right tail test, or two tail test? Well, here mu is larger than mu 0, right? So when it's larger, remember when we have mu larger than mu 0, so here mu larger than mu 0, so mu larger than mu 0, so that will be a right tail test, okay? So here, so mu is larger than mu 0, right? In this problem, mu is larger than 14, so this is a right-tailed test, okay? And when it's a right-tailed test, it's just one tail. It's just one tail area. Okay. If it's so, when you have a left tail test or right tail test, there will be one tail area. Okay. And if you have two tail test, okay, so there will be two tails area. Okay. So if you have left or right tail test, there will be one tail area. But if you have, two tail tests, so there will be two tails. Okay, right tail or left tail test, so there will be one tail area. And if you have two tail test, there will be two tail area. Okay, so here we are in one tail area. So how do we find the p-value? We're gonna use the student t distribution. So we're gonna use table 4, the student t distribution. So in the table, you can see, so in the top here, so you have, in the top you have, so because we are interested in one tail area, so we're gonna use the first row, so that's one tail area. So in the first row, you can see you have like, 0.25, then 0.125, etc. And then, so 0.125, then you have 0.100, okay? And then 0.075, okay, etc. So actually this first row, that will be your p-value. This is your, here, the first row is your p-value. This is your p-value, okay? That's your p-value. Now, degree of freedom. Well, in this problem here, the size of the sample n is 10, right? So the degree of freedom, df, degree of freedom, so that's n minus 1, so here is 10 minus 1, so there'll be 9. So here, and the degree of the freedom, so we have 1, 2, 3, 4, 5, etc., and then you have 9, okay? And so you can see here the values, so you have like, here you have like 0.703, then you have like 1.230, then you have like 1.383, and then you have like 1.574, okay? So these values here, they represent your critical value Tx bar. So your Tx bar, so your T is equal to, your T is 1.386, right? So 1.386 is between these two values here. So it's between, so 1.386, so it's between 1.383 and 1.574, okay? So your your p-value is going to be between 0.1 and 0.075. So my p-value, is going to be between 0.075 and 0.1. Again, the first row in the top, the first row, that will be your p-value. And your t, you got, so our statistic test, t, so we got 1.386, which is between these two values, right? 1.383 and 1.574, which is between 0.1 and 0.075. So the 0.1, 0.075, that will be your p-values, okay? So your p-values between these two values. And so now we compare p-value with alpha. So alpha, it's given in the problem. So alpha, we said, where is it? Alpha, I forgot to mention alpha here. So in this problem, alpha is, again, let's say 0.01, okay? So alpha is 0.01, alpha 0.01, but anyway, your p is between 0.07, right, and 0.1, so which means obviously p is larger, p value is larger than alpha, okay, because p is actually between 0.07 and 0.1. And your alpha is equal to 0.01, okay, so your p-value is larger, okay, so we do not reject the null hypothesis H0, okay. So the interpretation would be the following: the sample, of the lab test does not give enough information that the hemoglobin count levels are higher for this patient, okay. So the sample, so this is our, so the interpretation is the following. So the sample does not give enough evidence or information that the hemoglobin count levels are higher for this patient. Enough information. Okay, enough information about the enough information that the hemoglobin count levels are higher for this are higher for this patient. Okay, so we do not reject the H0. So there's not enough evidence that the hemoglobin count average for this patient is higher than the 14. Okay. Anyway, guys, you can find there are more examples in the lecture notes, and I guess I'll stop here. I will see you next time. Thank you.